Hi, this is Vivek and today we are talking about this equation AX plus BY equal to C, a linear Diophantine equation. Just a big fancy name for a simple thing, right? But we want to find solutions for this. We want to find all solutions for this. We want to find different conditions, maybe solve some problems, and that's what we'll be doing in this particular video, right? And I think this is one of the most crux idea that lies like as a core to a lot of number theory that you would require for DSA and CP in general, right? So a lot of things like the Chinese remainder theorem or many other like relevant results that you try to use after this is what can be derived by fundamentals from this equation, if you can understand what these equations solutions look like and how to solve that, right? So that's what we'll be doing today. We'll be kind of getting into deep depths of this particular equation and we'll be solving questions related to it, right? So I'll be giving you a list of questions also in the description to solve after you have watched this particular video, as many of you asked me in comments, right? Also, if you guys have been watching my video for a long time, like if you like these kind of videos, definitely subscribe and like the video and write down like what you would like to see as change in the videos in the comment box. These things do help me make more such videos, right? Let's move into the video. So the prereq over here is to kind of know a little bit of number theory terms, and I will teach you the ones that you need. So there is this Z or Z like written like this a little bit, right, which you will see in number theoretical books, right? So this is nothing but a set of integers, like minus infinity to infinity. There are a bunch of integers and we are dealing with that in Z, right? So Z is like a set for that, representative set for that. Okay, I, it's not an I actually, it's like the bar over here. That basically means divide. So let's say you have A divides B. So this will be read as A divides B, okay? And when you say divide, it's basically like A is a smaller number and B is a multiple of A. That's what divides mean, right? And then there is GCD, right? I hope all of you guys know what GCD means. GCD is the greatest common divisor. So basically if you have A comma B, you want to find a number which is largest and which divides A as well as B, right? That's what we are interested in GCD. Find largest such number which divides both of them, okay? So that's the prereq. If you know all of these things, you are good to go with the video, right? So we're going to learn a little more about GCD. Like how do you calculate GCD? Like I don't know how many of you know about GCD's algorithm, but there is a very fancy algorithm, right? But we'll kind of derive to that. A very simple fundamentals of GCD of A comma B is like GCD is going to divide A and GCD is also going to divide the B, right? Now there are two simple things that we should first of all realize. One is GCD of A comma B is GCD of B comma A as well. Like you can swap the values and it doesn't change, right? Because it's an independent property of the two numbers. The next thing is GCD of A comma B is same as GCD of A minus B comma B. Okay. If you subtract one of them from the other, it's still going to be relevant. You can still find the GCD of those two things and you are good to go. Why is that? Because if a number is there which divides both of them, the number will also divide its difference, right? So now you are basically saying that if these two things are true, then and the G is the largest number, then it gets to this. Now if this is true and this is also true, then it kind of leads to this, right? And we know that these are actually same. It will not change because G is same, right? The largest number which divides both of them. So this is also true. From over here, we can maybe also do it twice, right? Why to subtract only once when you can also subtract it twice? Or maybe subtract it as many times as you can do it, right? That's something we can do. So if we subtract it as many times as we can like do it, we will get to a point where we will subtract it exactly A by B floor number of times. This is the maximum number of times you can subtract B from A, floor of this times B, right? And if you know about remainders, like what is remainder when you divide A by B, this is the syntax for that in C++. So you want to find the remainder, you basically do it like this is nothing but the remainder, right? This is the quotient. If you remember Euclid's equation, A is equal to quotient times B plus remainder. Q is nothing but A by B in coding. R is nothing but A mod B in coding, right? And you can see that we have just put in over here and moved to this side. So that's the R. So R times B. And now we know that remainder is less than B. So it's also equal to GCD of B comma R, right? So we know that GCD of A comma B is equal to this and it's equal to this, equal to this, equal to this, and we know this. So we can directly say that this is equal to this, right? The GCD of A comma B is equal to GCD of B comma R, okay? And this is a very, very nice property, because now we kind of like moved one of them to the other side and the other one we took a remainder. Now in maths, like try to think about these properties well. I'm gonna like ask you a quick question. What is the maximum value of x mod y given y is less than equal to x? Okay, what is the maximum value of this? It turns out the highest you can go till is x by 2. Okay, remainder, taking a remainder with any value which is less than equal to that number, halves that number. This is a tool. Think about it. Why does this happen? Because if y is bigger than x by 2, then the remainder is going to be at least like 1 times it will get subtracted. So it will be less than x by 2. And if it's small, then the remainder can never be more than y. So both ways it will be less than equal to x by 2. So this number, or let's think about over here, this number suddenly dropped by half. And the next time we swap it and do it again, the b will also drop by half at least. So in 2 steps of GCD, we are halving the whole step. So this is one step. We will simply do b comma a mod b, which is the remainder. And then again do one more step, and you got 2 steps of the GCD algorithm, and you halved both of the values a and b, right? So in log n, 2 times log n steps in the worst case, you can actually find out the GCD of a number. So this is how GCD works. GCD's algorithm, core algorithm works. And this is the very fundamentals of all of number theory that you will need, right? Right? So let's move forward. So this is the GCD's property that we have as a like solution equation that we can use, that hey, GCD of a comma b is equal to GCD of b comma a mod b. Okay, this is what we will find out. This is a recursive solution. And when will this stop? When, let's say, this becomes 0, like when a is divisible by b. So when a is divisible by b, then b is the remainder, right? So when this is 0, b is the GCD. So you return the b. When this is 0, this is c. So this is the base case that we write in such GCD equations, right? We will go into depths of this. We'll write code as well, and not write code. I have that on my slides, so I'll directly use that from over there. But let's not think too much about coding right now. Let's think about how is this working theoretically, right? I think coding number theory solutions are pretty easy. It's not that tough if you have the like snippets and stuff that is needed. Most of them are available on CP algorithm and stuff, right? So that's not tough. Mostly the hard part is to kind of derive the things theoretically, and then plugging in the things is very simple. Okay. So what exactly happens when you have an equation like this? Is there a solution for these equations, right? Is there a solution for this equation? I don't know, maybe there might be some. And for this one, it turns out no, this doesn't have a solution. Why? Why doesn't this have a solution? Very simply, like you can see that 2x is an even number, right? 6y is an even number. So this left hand side is an even number, and this is an odd number. Can that ever happen, that an even number is equal to an odd number, right? No, right? Why did that happen? Because 2 divided the left hand side, but 2 did not divide the 5. That's not possible, right? In fact, the general version of this is, let's say you have some AX plus BY equal to C. So you have to find the value of X and Y. So there is a GCD for A comma B, right? There is a GCD of A comma B, which divides the left hand side because it divides A and B. So it will divide the left hand side. So if the GCD of A comma B does not divide C, then there is no solution. We can simply say no solution, right? If it does not divide, there is no solution for sure. We can tell that, right? What if it does divides? Okay, what if it does divides? So necessary condition for having a solution is it should divide. If it divides, do we always have a solution? And it turns out magically, yes, that's true. We always have a solution if it does divides this, okay? And when I'm saying solution today, we are talking about the Z or the integers that we talked about, right? Because fractionally though, this is gonna always have a solution. If you think about like a 2D plot, what is this equation looking like? It's like a line equation, right? What we are trying to find out is integers points, both coordinate integers on this line. That's what we are dealing with in today's problem. So fractionally though, we have always a solution, but we want to find integer solutions. So if the GCD divides C, if GCD of A comma B divides C, always a solution, And now you might tell me, hey Vivek, why is that always the case? Can you prove it? So we will prove it using the algorithm that finds it, right? We can find a solution. So we will have an algorithm that will find it, and that's the proof. We don't want to do it too much of theoretical proofs and all, because a lot of these things would be used in coding, and we have ready-made things to do that for us. Like, we don't need to go into proofing things every time, right? We have just code snippets that can do things for us. So we'll talk about it. In fact, there is an algorithm that can solve equations like this, find solutions for this, right? So we can find solution for this, and that's why there is always a solution. Now, how to find that? Okay. So how to find any solution? Like, tell me any solutions for this. Think about any solution. If I had to print one solution for this, I would do maybe like 3 times 2 plus 4 times minus 1, integer, right? So negative numbers are also allowed. So 3 times 3 plus 4 times minus 1 would give us 5, because this is nothing but 9 minus 4. 9 minus 4 is 5. So 3 comma minus 1 is a solution for this particular equation. So that is something we know. But how do we find this algorithmically? Okay, how do we do this algorithmically? The way to do that would be to actually find out, the first step would be, number one step would be to find a solution for 3x plus 4y equal to the GCD of the two numbers, 1. GCD of 3 comma 4 is 1. So we will find the solution for this. And the next step would be to go to the equation equal to C. So the first step would be AX plus BY equal to C, convert it to AX plus BY equal to GCD of A comma B, right? And from over here, you again like just multiply things. Let's call this X dash Y dash, and the actual X and Y will be nothing but a multiple of this, right? So we can go that in the second step. So from over here, we will try to find out a solution for this. Maybe let's do that. Let's find out one solution. So I can see Y equal to 1, X equal to minus 1 is a solution, right? Minus 3 plus 4 is 1. And then if you want to find a solution for this, from this satisfies this. What will be a solution for this? Maybe if I just multiply both with 5, right? I mean, it's like we know 3 times minus 1 plus 4 times 1 is equal to 1. Multiply 5 on both the sides of the equation, right? So it's like 3 times minus 1 times 5. I'm just putting that 5 inside over here, plus 4 times 1 into 5 equal to 5. So you have now one solution for equal to 5 case, right? Very simply, you have the solution over here available. So minus 5 comma 5, and you can actually put in, right? Minus 5 would be 15, minus 15 plus 20 to 20 minus 15 is 5. So we got one solution, right? So we first convert it to this equation, find out a solution, and then go to this. Now over here, we also did it by hit and trial, right? Minus 1 comma 1 was a hit and trial solution. We didn't really do some algorithm for that. And it turns out that there is an algorithm that gives this to us, right? Let's think about a black box for now, that there is some black box which is available, which given this equation that, hey, give me any AX plus BY equal to GCD of A comma B, I will give you the solutions for that. Okay, it will give you this solution. So now we can solve this question if we have this black box, right? Okay. Before we try to open this black box and see what's inside it, what code solves this every time, and why does that code work, okay, we will try to use this black box and try to find not just one solution, but all solutions. Because see, it's a linear equation, right, where you have two variables and one equation. So there should be multiple infinite solutions for this. So if you found out one solution, can we find all solutions, right? Let's move into that. Is there only one solution? It turns out no, right? Because you can find one solution 1 comma 1 very easily. But what are the others? What are the other solutions over here, right? Okay, so how to find that out? So you know one solution, let's say 1 comma 1 solves this equation. Okay, let's say that like any other solution would be of the form 1 plus some integer u, 1 plus some integer v. Okay, and you plug this in back in equation. So let's say if you plug this back, you will get 10 times 1 plus 10 times u plus 15 times v plus 15 equal to 25. And obviously this 15, all of these things get cancelled off, and you will get 10u plus 15v equal to 0. Okay. Any u comma v that satisfies this equation equal to 0 will be a general solution, right? How do you find the general format for that? Simply try to write it in terms of one variable, u equal to 15 times v by 10, right? Now u has to be an integer. What are the values of v that will make this an integer? Think about it. what I can see is if v is even, right, it will actually be always an integer. See, 15 is not 15 will not give an answer, but 30 will give an answer. 45 will not give, 60 will give. V has to be even, right? How are we getting that? So to some degree, this is getting cancelled off by this, and you get 3 by 2, right? Sort of this. I would rather write it this way, equal to 15 by 5 times v, right? 10 by 5 times this, okay? So this is how we write it. Now, there is no common factor between this. So to get this as an integer, this should get cancelled off by this only properly, right? Like this should be a multiple of this number, or this should be a multiple of 2. So v should be of the format 2m. Plug in 2m over here and you get, okay, sorry, when we converted this, you should minus, right? We moved this to this side, so it should be a minus equation over here, correct? So you plug in 2m over here and then you get u is equal to 2 times 2 gets cancelled off, m multiplied by minus 3, so minus 3m, right? That's the general version. In fact, if you have any u comma v of this format, you will get a solution. So plug this back in over here in this equation, you get a general format for this as 1 plus 2m comma, sorry, u was minus 3m, so I should plug this over here. This is the general format. Any plug in any value of m belonging to the integer realm, plug in any m and you will get 1 by 1 solutions, 1 by 1. Okay, 0, 1, 2, plug everything and you will get all the solutions. And that's how you find out all the solutions, right? How does this work for a general equation? So we had ax plus by equal to c, right? So let's forget about c part for now, GCD of a comma b. This is the reduced equation, right? And somebody gave you a solution for it as x dash and y dash, which solves this, okay? This black box that we talked about. So what we write for this is x dash plus u comma y dash plus v. We are solving it in a general way right now. Plug this back in and you will get a times u, because ax plus by dash, ax dash plus by dash is actually equal to this. We know that, so it will get cancelled off. So au plus by is equal to 0 is what you will get always, okay? From over here, we have to find out, sorry, AV, this is not y, there is no y anymore, y, so we substituted and it cancelled off, right? V equal to 0. From there, we get u is equal to minus bv by a. So for this to be an integer, v has to be a multiple of what number? A by GCD of a comma b. This is very, very important. V has to be a multiple of m times GCD of a by b divided, like a divided by that number. Why is that? Because other, like the GCD part will get cancelled in these two numbers, right? And then the other part has to be handled by v. So that's why this has to be the common multiple. And if you plug this in, like basically it will be nothing but minus b by g. G is the GCD, a by g, just divided both of them. And then this is nothing but m times a by this. So a by this is only over here, so it will get cancelled off and you will get u as minus b by g times m, right? So v is of the format m times a by g, u is of the format minus m times a by g, b by g, sorry, right? Plug this back in and you get a general solution, okay? So what steps do we follow to solve any equation? Ax, not just this, ax plus by equal to c. How do you find a general equation, general value for that? Let's say you have ax plus by equal to c. First step, convert it to ax plus by equal to the GCDG, okay? Solve an equation for this, find out x dash comma y dash, which substitute this, okay? Then convert it to a general format, not general format, you have a solution for this. The actual solution for this would be actually nothing but, so see, it was equal to g, but we want c. So we will multiply this with c by g, because on this equation, we are multiplying both sides by c by g into c by g. So the equations will also get multiplied by c by g. So the general solutions for this is x dash times c by g, comma, y dash times c by g, okay? Now what we want to do is, we want to find general format. like there is an m, and find all solutions basically. So what we do is we get to the core equation, which is a times u plus v times b equal to 0. We try to solve this, and we know that from the last slide we already did this. We got u is equal to minus b. So u comes like from b times g times m. V comes from the other variable, not minus, a by g times m. Okay, and the general format is the solution x dash times c by g, general version, plus u minus, I would try to write minus over here, and then in this side you have y dash times c by g plus a by g times m. Now it's an exercise for you. Put this back in this equation and see if it's actually satisfying for any different m. Everything should get cancelled off, and it should be 0 equal to 0 for, it should not depend upon m. Plug this back in and see if it's working. Okay. So that's pretty much the way to solve these questions in a general way, like finding out a general equation for this. And that's what you would have to use, right? Pretty neat. Now, how do we go forward and maybe like find out this black boxy thing? Like we said that there is a black box giving us this, right? How do we do that? Okay. Turns out there is this algorithm. There is this main algo, which I've taken as a screenshot from the CP algorithm, which solves this, right? And for the longest period of my time, like when I was doing competitive programming, I took this as a black box. Ki, acha, there is something where you give, if you give the AX plus BY equal to G equation, just give the A and B, and it will find you X, Y, and G. Find out the GCD as well as it will give you X and Y, a solution for that. This code does it. But now, since we have kind of grown past the phase where we just should know things like a black box, ideally I don't want to keep that the agenda for this video. Let's try to understand why this works, and it's actually very simple. The time when I realized it, I thought like, I should have learned it in the way how to derive it, and then you will not have to memorize this code, right? You can actually derive it every time. It's not so hard. Okay, how does this work? How does it find us one solution, x dash and y dash, for this equation? Okay. First of all, forget about this x and y, right? Forget about this lines, this x and y, right? See, what is it doing? If a is a and b, it's going to b comma a mod b, the remainder thing, and just returning the remainder, right? And when the b is equal to 0, just remainder is, the GCD is a. So it's finding the GCD in a recursive way, very simple recursive code, okay? But now we have x and y as well. So we want to find, we know that it's finding GCD correctly. The return value is GCD, right? The return value over here is GCD. How does it find A and B correctly, right? And there is some weird magic done over here, if you see. What is this, right? So the way it works is we want to find the solution for AX plus BY equal to G, okay? If you recursively call this same thing again, and if it is working properly, right, it should ideally return us the solution for b times x dash plus a mod b times y dash equal to g. Okay, say that this returns us, if you call one step deeper, it will return us a solution for this equation. B, and with the variables being b and a mod b, it finds us the solution for that and the GCD. Okay, this GCD we are directly returning, and for x and y we are computing something on this. Okay, now at the base case, see, when the y is equal to 0, x is obviously equal to 1 because the GCD is nothing but b, right? GCD is, when the GCD is a over here, x is equal to 1, like when this is equal, this GCD, this part is 0 when b is equal to 0. Of course, y is 0 and x is equal to 1 is a solution because this is nothing but g, right? So that's true. So base case is working fine, but if you know the solution from this, how do you find out a solution for this? That's what we want to do. And there is a very neat way to do this. Okay. The way we can do this is we can just simply think about, hey, tell me, how can I get from this equation to this equation? Okay. We try to write this in a different way. We try to write it in a way that, hey, maybe like, let's go this side a little bit so that we have the implementation on the side. We have b times x dash plus a mod b times y dash equal to g. But a mod b is nothing but a minus the floor function with b multiplied by b, the remainder. Remember, we are replacing this with the quotient and the remainder terms, right? So this is the remainder. So we can write it as b times x dash plus a minus a by b, the quotient, times b. Okay. And then from there, we can just open up the brackets and try to keep it like in the format ax plus by equal to g. So a times y dash plus b times x dash is over here minus b y dash a by b. B is getting common out. So a by b times y dash equal to g. Okay. So from this solution, we kind of manipulated it and got something like this. Does this look like ax plus by equal to g? Doesn't it? It does look like ax plus by equal to c. So we can simply say that this is nothing but our x and this is nothing but our y, right? And that's what they are even doing. If you see the code, x is equal to y dash, y1 is y dash, y is equal to nothing but x dash minus y dash multiplied by a by b, isn't it? That's what this code is doing. We're just simply assuming that, hey, this is how the format ax plus by equal to c. Why not just use the same values and just treat it like the same solution directly? Just compare and get the values, because there are infinite many possibilities, but we just have to find one. So just copy it like that itself in the variables, right? That's what we are doing over here. Right? And then we return. So if you do it recursively, if the lower equation could get a solution, we can get the solution for the upper equation and we go back up the recursion loop, right? So that's how this particular equation finds the solutions, and you can get the value of ax plus by equal to g directly like this, right? So this is how this equation works, and this is a very, very neat way. I for the longest bit of my time, like, could not really get my head into like the proofs and all. I didn't want to get into it, but then when I realized this is what it's doing, I thought, hey, that's a really nice way thinking, right? And you should actually know the proof. It's very simple to actually remember the proof rather than like just remembering the code. Okay. So this is how you find GCD, and this is called extended GCD's algorithm or extended Euclidean GCD algorithm. That's what it's commonly known in CP algorithm. Okay. And you can see the code. I will give the link in the description as well. So you can use this and you can find the GC solution for this. And then you can use that in the flow over here. We have this from the black box, the code, and then do these things manually in your code. Okay. So that's pretty much on how you find GCD and the solutions for the equations. You now know the way to go to the GCD equation, find out one solution, go back to the original equation, find one solution, find all solutions, all of these things you now know, right? And that's very neat. Let's kind of take some problem, right? Let's take a very interesting problem. And this is, I think, one of my personal favorite problems. That when I saw it, I think I immediately thought, hey, this is a really interesting idea and I should maybe make a video where I talk about this. Okay. So let's say there is like Sunita goes to a bank and she wants to cash a check, right? The absent-minded teller gave her like as many paise as she should have been given as rupees, and as many rupees as she should have paise, right? If there is an equation where it's x dot y, right, x rupees and y paise, the teller gave him y rupees and x paise, which is very weird, right? Actually, it becomes very significant if it's not two-digit numbers maybe, but yeah, that's something that happened with her, right? Now, like Shnita also like left with this. It was only after she spent 5 paise, she noticed that she had twice as much money as she should have, right? So whatever money she should have had got from the bank, right? She has twice that money after spending 5 cents or 5 paise, right? So what is the amount of her check? What was the actual amount? You have to find out the actual amount just by this much equation. And you would tell me, hey Vivek, there is nothing of information over here. How would we find it out? Just one number is there, 5 paise, right? How do I find out the original check? Let's try to write equations and see what comes up, right? So the original amount was something like x dot y, some x rupees y paise, and then she got y dot x, and after spending 5 she had twice this money. So 2 times, so this is rupees, so 100x plus y, so we are converting everything to paise, is equal to 100y plus x. This is the rupees she got, the paise she got, minus 5 paise. So this is actually going to be equal to this equation, like twice the amount of money that she should have actually received, right? So this is the equation given to us, if you think about it, right? Let's try to kind of reduce it a little bit. 200x minus x. So I can see 199x, right? A lot of 9 so here. And then 100y minus 2. So maybe minus 98y. Okay, so we are shifting these over this side, equal to minus 5. Okay, and negative number doesn't suit on this side, so maybe let's shift it this side. Okay, so 98y, or I'll write it this way, minus 199x plus 98y equal to 5, right? This is the equation that is satisfied by the x rupees and y paise, whatever was given to what was the checks thing, and we have to find x and y. But again, the question lies the same. Hey, we have just one equation. How do we find the value of x and y? Think about it. This is a really good problem. If you have not thought about it till now, pause the video, think about how do you solve this. Okay? And I will actually wait a little bit for you to give you a nudge, karo, like do it, try to solve this equation. Okay? I hope you have tried it now. So let's get into it. So this is the thing given to you, and this is the equation. Let's move to the next slide. So the equation that is there with you is 199x plus 98y equal to 5, right? So first of all, what do? We do the check that does it work? Does it divide this? So we have to find the GCD of the left hand side. The divisor of the left hand side, which is the GCD. What is the GCD of 199 and 98? 1. You can try it. 98 into twice is 196, right? So 3 difference, 196, so it will not work. So 1 is the GCD. So it's fine. We can always find a solution because 1 divides this. So we have a solution. We will have a solution for sure. So what we can try and write is, we can try and write this as 199x plus 98y equal to 5 equal to 1, and maybe try to find out a solution for this, right? Maybe try to find out a solution for this. How do we find out the solution for this? The algo, the code, just plug in these values. Just plug in a equal to minus 98 and b equal to 98 in this code, and it will actually find you the thing. Okay, not to worry about it. It doesn't need a and b to be like necessarily positive always. Okay, and plug in negative numbers over here as well. Okay, so this is what you give to the algorithm, and it will give you a solution. So since we don't want to write the code right now, I will just plug in the values and I will tell you the solution. So what can be one solution? Maybe minus 33, and this will be minus 67. Okay, so these are two solutions which if you plug in, you will actually get a solution, and you can try it out. Since this is computer generated, I'm just directly using it. Okay, so minus 33 and minus 67 are the two different things which gives you the solution for this. Okay, so we have one solution. How do you get back a solution for this equation? We plug this in and then we multiply it with 5. So one solution for this is this multiplied by 5. So maybe we will get minus 165 comma this multiplied by 5. So then this would be minus 335, right? 35, so 30, yeah, right, correct. Cool. So this is the solution for this equation, right? So you got one solution for this equation, which is pretty good. It's pretty good. How do we deal beyond this? How do we find out, apart from this, how do we find out any other solution? Okay, how do you find any other solution? Any ideas, guys? So we found one numbers, but these don't look like the values of the check numbers, right? We have to find x and y's. what is the general format in that case? I can simply write the general format 165 minus what do we write? X as, let's say, I can write a general format for this. That would be nothing but, let's say, what do we take? So GCD is 1. We can put this as plus 98k. Like, because the GCD is 1, it generally copies, it's B by GCD. And the other thing would be minus 335 minus the other number 199 by GCD. So that k. Oh, so minus 199. So this will become plus. Okay. Yeah, this seems right. This solution multiplied by this into k, and this solution multiplied by this negative of this, so minus 199 into k. By GCD was there, but GCD is 1, so there is nothing more. Right? So this is the general format. Now this is a possible value of x, and this is possible value of y. Okay, these are general possible values of x and y. But what now? How do we find out the solution now? Okay. So let's move to the next slide. I think that would be a little better. So our x is equal to nothing but minus 165 plus 98k, right? And y is equal to minus 335 plus 90 plus 199. Okay. Now, very interestingly, there is another relation that is given to you, which is hidden in the problem. Can you find it out? It's a very, very interesting idea. Think about it. What is that one more relation that is given in the problem, but you didn't think about it? The numbers are always x dot y and y dot x. These are valid rupee paise combination, right? So can I say that x is up till the value 100, like x is going to lie in the range 0 till 100 till 99, I would say, right? And then, sorry, this x over here, and then y is also going to lie in the same range, right? Both of them are like greater than equal to 0 and less than 100, right? So x comma y, both of them less than 100 and is greater than equal to 0. This is another relation given to you. Okay. And that's pretty interesting if you think about it, right? Let's try to use this equation. So x is greater than equal to 0. So we plug in these values. So you will get x greater than equal to 0 means this equation greater than equal to 0. So that will be just shifted to this side. K is greater than equal to 165 by 98, right? This will come somewhere around how much? Maybe 1.68. Okay, something around 1.68. And the other equation is also y greater than equal to 0. So k is greater than equal to 335 by 199. This will also come out to be around greater than equal to 1.68, right? More than 1, less than 2, whatever that is, right? Then you have equations like it's less than 100. So x or 1 minus 165 plus 98k is less than 100. So from over here, what you get is k is so 265 by 98, so 2.7ish, right? 2.7. And then over here, minus 335 plus 199, k is less than 100, strictly less than 100. So this will give you k is less than 2.18, I suppose, right? This is going to give you k is less than 2.1. Just move it this side and do this. So k is less than this, greater than this, right? And k is an integer. Remember, k is always an integer. So what's the value of k? 2. Makes sense. So we found out k equal to 2. Plug these values over here and see k. If you put k equal to 2, you get x is equal to 31 and y is equal to 63. So the actual amount was 31 rupees 63 paise, but by mistake she got 63.31. And then if you subtract like 5 from this, from what she got, right, she has the twice the amount of this. If you subtract 5 from this, you will get 0.05, of course, 63.26, which is twice the amount that she should have received over here, right? So you actually could find what's the value of the check, and that's pretty nice, right? So that's an interesting kind of a problem which I found pretty valuable. I mean, this is very interesting idea that you can actually find out the number by just one number given in the problem. And when I first saw this, I was like, why, how is this even possible? But then when I started scribbling this, it was actually possible to solve it, right? Okay, so that's pretty much like the use cases and the like using of the algorithm that we talked about. There is many more such use cases. I will list down many problems down below. As a quick thought activity, I'll give you like one problem. So you are given AX plus BY equal to C, right? And there are many solutions for this. Find the solution that has minimum value of absolute of X plus absolute of Y. Okay, find out one solution for this equation which has minimum absolute of X plus absolute of Y. That's something that you'll have to solve. Okay, so this will be a quick task for you. Let me know in the comments if you could understand all of these concepts and try to write the equation, general equation for this, and see how the graph for this will look like if you try to do that, and try to find out where will it actually find the optimal value, right? So try to do this. Okay, if not, I will help you in the comments. Feel free to write down maybe what are your thoughts and all. Okay, and I will let you go through the problems in the descriptions as well to get a practice on the coding side. It's going to be problems from the CP algorithms itself. It's a pretty standard list, so I will recommend that itself. Okay, I will link the blog for CP algorithms extended GCT thing over here, and you can actually try to go and read about problems like Chinese remainder theorem and derive it from the first principles using this. Okay, so this is the place where we'll stop. I hope these learning videos are something that is encouraging you to learn these ideas and like solve better in a better way in problems which need these. Like definitely I'll go and ask you for a quick like and like subscribe if you haven't done that already. And in the next video we'll meet again. We'll learn something new. Till then, see you all. Bye bye.